Okay, we're trying again. I cannot hear myself, so okay, I think we are good. Bitrate is sucks, by the way. Poor network connection. Okay, it's actually fine. Alright, so basically I have an idea to do streams where I will watch cool stuff on the YouTube about React Native, like some tutorials like this one. See, it's something super cool, and I will try to implement it myself. So yeah, let's just start. We need new project. There's the link below the video. Is it to use the expo? I believe so. Or no? Let's have a look. No, it's not expo, but yeah, we will try with expo anywhere. So expo start. Pixelated image. Okay, so we can do npx yeah. Okay, so pixelate, how it was called again? Pixelated image, pixelated image project. Okay, it's TypeScript, which I like. Okay, it's created the project, just a bit slow, but we have it. But actually it's not what I want. I want template with a TypeScript at least. quick start. Let's try TypeScript. So basically, let's remove the project we created and try create with the TypeScript template. And let's see what will happen. Yeah, now it's TypeScript. Version 9. I think I'd like to install Prettier. Oh my gosh. And yeah, I need Prettier config. And let's restart our new Vim. Okay, formatting works, and I think it's good enough to start. So let's back to the video and let's create this new component, Pixelated image screen. So basically the view component, add import. Yeah, maybe let's also add some text. Just to test it. Okay, view. And let's start our simulator. Okay, agency simulator is running. So maybe this is mini sim. Okay, now it's here. Xpego is outdated, would like to upgrade. Yes, let's do upgrade. Maybe we can squeeze the view. Don't think we need to center it. And pixelated screen. We have style width and height 100. So let's do this. Height as well. Let's test with some background color. Yeah, it works perfectly. So we can move on. So we add in some constants like friction and move speed. Okay, get in window dimension. Use window dimension and import it from the React Native, and then the width is stage width and also height as stage height. Okay, next step is already using the Skia, so let's take a look how to install it first. React Native Skia and documentation. Alright, is any expo? No. So maybe let's check Skia installation in the Expo docs because we're using Expo. And yeah, let's just do this. Yeah, just quickly check how the stream is going. Looks fine. All right. So we did install Skia. For web, we don't interested in web right now. Usage. No, we're not using bear and so it looks like we don't need to do anything here. Something for just the plugin. So maybe let's quickly try the hello world component example to see if it works. So just paste it here and use hello world component, and I think we need to actually restart the expo. Oh, it's don't really need restarted, but yeah, let's run it again anyway. So hello world is working, so we can continue with the tutorial. And let's back to it. So created canvas and mode continuous, and style will be stage width and height. Okay, let's do the same. Mode continuous and style width is stage width and height. So yeah, let's quickly take a look what is the mode parameter. Canvas is updated when the drawing, tree or animation value changed. Okay, is not continued. The canvas will redraw on every frame. Interesting. Maybe what we can do, we can later try default and see the difference. Really curious what the difference will be, but for now, yeah, let's move on. Drawing. Okay. Yeah, it's actually first time I'm trying to do something with Skia. I hear about it a lot, but yeah, no chance really use it for my work. Yeah, let's quickly jump back and add this called drawing. So we'll do drawing. Let's add to the import. And drawing will take canvas. Okay, and canvas clear Skia. So I guess Skia is the global import. No. Skia color. Okay, I don't see such import, so let's back to documentation and maybe just search for color. Color shader, not what we're looking. The LARP, definitely not what we need. Shapes, filters, box. Yeah, not obvious where it's coming from, so let's jump on the source code of this video, and here's we have the screen pixelated image. Okay, Skia imported like this. And can I find Skia Wallace? This is about animations here. Oh, nope. Okay, let's try do it like this. Yeah, you see there is autocomplete, and what we actually put here in the tutorial is just string black, and close the tag, and let's see. Yeah, it's actually black background from this color. So if we do purple, for example, yeah, it also works. So let's back to the black and continue. Okay, now have some utils file and create some type particle xy saved x saved y x number y number saved x number saved y number. All right, vx vy vx vy and picture Skia picture. Okay, automatically imported. Okay, export make image particles image Skia so you see here we have Skia picture, but here is Skia image. Interesting. But okay, density is a number, stage width is a number, stage height also number, and okay, that's it. And we will get a result as type I particle, and it suggests actually array. I guess it's correct suggestion, but yeah, fix a typo. And let's move on with the video. Paint, Skia paint. Okay. Skia paint. So yeah, let's start with two loops over stage width and height, and step will be density. Okay, let x 0, x less than stage width, I guess, and x was equal density. Am I done it correct? Yeah, looks so. So let's do copy paste. And stage height. All right. So we create a picture. Which is function from the Skia. And we put direct I'm not sure where from this rect coming from. Okay, I just misspelled it, so maybe there is some autocomplete. Nope. Oh, there's actually direct function again from Skia, and we create the basically rect with density size. Okay, this is more or less clear. We do canvas. Alright, there is also canvas in this function argument. Translate. I feel like something not okay. Yeah, I did it the wrong way. This direct is the first argument and the function which receive canvas is the different one. So we do translate minus x and minus y canvas, but I'm not sure yet, but I think we will find out when we draw something and can experiment with it a bit. Because right now it's not obvious what we're doing here. It is just from code. Okay, we create some paths. Clip pass. This clip pass make and yeah, clip pass add circle. The size and what? Where's the size is coming from? I'm not sure yet. Let me quickly check. Yeah, I'm still fine with my camera. So yeah, let's take a look what the size is. Did I miss it somehow? Utils. Oh yeah, it comes as prom. So Yeah, size number. Then we're doing canvas clip pass. I don't know, I just put something Copilot suggest me. Let's compare what we have. Clip, op, intersect, true. Does not exist. Okay. And intersect. Close, but not really what we need. Copilot fool us a bit, but it happened all the time. Draw image rect. Okay. Canvas, draw image rect. Image. Okay, I'm lost again where the image come from. Did we have image somewhere already? Oh yeah, it's again, it's yeah. Sorry guys. Image. So what we're doing here is image width, image height, is it what we're doing? Yeah, rect, image width, image height. Expected 4-5 arguments, but got only 2. Yeah, what else we need here? Okay, so first rect is rect where we drawing, second look like it's stage width, stage height. Yeah, second one is the canvas size, I think. Yeah, we might be. We'll read documentation a bit more once we have something working. We will try and understand each step better. And now let's just continue. Okay, and we push the values to our result. Okay, we created the picture and then result push x y saved x saved y vx. I guess it will be velocity, but not sure yet. And picture. All right, I think we did it, and I hope we will be able to draw now with this function. Oh yeah, of course we need to return a result. Okay, use image hook. Okay, this is the URL, and I guess we can do it like this. Use image from Shopify React Native Skia, and yeah, just put the string there. Okay. Say what if no image? We will be a bit more explicit here. Yeah, align item center as well. No image. And I think this is something we can test. And yeah, works. We break our URL. It says no image. So far, so good. Okay, and now we can do particles with our function. And draw particles in loop. Move speed. So yeah, first of all, let's create particles. Make particles image stage width stage 8. If I remember it correctly, so image density size state width state 8. And yeah, inside drawing, do let I0 to our particles, particle. All right. And now I just want to see the final code here. Okay, this is interesting. Let's do canvas save, canvas. Actually, this recommend for a second, then canvas draw. And draw picture and canvas restore. Interesting. And oh, was it crashed? Let's just restart. And we see nothing. So let's try to translate. Okay. So this is basically drawing. And why do we need translate? I think this is because we do translate it here. And then Okay, let's explain a little bit the situation. So we move it, then move back. I guess we need it for this movement feature. So let's add this code on particle X plus equal saved save x minus x and the move speed. I don't know why it's lowercase here. Let's do it uppercase. So same for y. With x multiply on friction. So 0 multiply on friction will be 0. Okay, and we put it back still working. Okay. Okay, gesture handler. Let's install it. Gesture handler. Run npx explain install, and meanwhile let's take a look at this import to the top of your entry file. Sure. What else we need to do? Looks like really nothing, but yeah, let's restart the expo. Okay. We are good here. And yeah, I think we can back to our tutorial, and we need pen gesture. Pen gesture from gesture handler, pen run on GS, on change event. So there is some mess here. I think we can ask Chat GPT later on what exactly we're doing here. I can't imagine what it is, but to be honest, haven't done anything like this last 15 years. So we calculate the distance between our pan gesture event and the particle, this little circle, and check if it's less than 100, then we do some stuff with it. So let's add this code for let e counts particle yep. Jesus bless the copilot. It's speed up me a lot on this thing, because I can just copy paste it, but it's not will come through my understanding as good as I will type even with Copilot myself. So on dist, alright, and mean dist, very well. And it pick up everything. So this is the angle from the axis to the point. I think I know what it's doing. It's like if you like press here and we have some angle like this line, and we want the particle move away in this direction, or for this particle in this direction. This is my guess so far. Vx, Vy. Okay, the Copilot actually fools me. We do subtract and he did addition. Maybe let's take a look what happened. Basically nothing happened right now. Oh yeah, we didn't attach pen gesture, I guess, to anything yet, so we need to wrap it in gesture detector and yeah, put gesture there. Yep. Over canvas, of course. So gesture detector, gesture pen, and yeah. And let's gesture tag must be used as a desk and the gesture handler root view. So yeah, we do install, we did it, then root. Let's compare to this source. Is there root gesture? Yeah, exactly. So we do the same. Add import. And yeah. Still nothing happened on press. Okay, and without this translate, nothing actually working. What if I do 50? Yeah, feel much better now. But yeah. So we kind of did it, but I think it would be nice to actually understand what we did it. So maybe let's take a look in the documentation. So let's keep the pan gesture for now, and maybe understand the drawing. So let's start. Oh yeah, and we can try default as we want, just quickly. It also works, but laggy. And this is what actually I expected in the first place. I'm also curious to measure performance of this, because it's cool by itself, but if I want to add it to some app, I would like to make sure performance is okay as well. But first of all, let's understand what we're doing here. So we have a canvas with style of width and height of our window, it's okay. Then we have this drawing component. Custom drawing. Allow us to use the creative UI with declarative API. So basically we have drawing function which do some drawing. It's how it's done back in the days, like if you go some native Android API, you can do some drawing in the draw function. Same for iOS, macOS. I did it a while ago, but yeah. So this is kind of clear for me. And we received the canvas as a param and paint. Yeah, let's take a look to the node first, please. Note that because this component relies on the JavaScript thread to be available, this component is expected to be slower than its declarative counterpart. Use with caution. If you are looking to animate on the number of drawing commands, we recommend using reanimated 3 with picture component. So my guess, what we're doing here, it's like happening all on the JavaScript side. We do recalculation and then redrawing. So for a real world application, I would like to have continuous for the time I'm doing gesture and switch to default once the gesture is finished. Because as I understand, it will draw each frame even nothing happened there like now. So default should be fine for the static, but when we want to press and do something, this requires continuous mode. Okay. Now let's back to, so yeah, I think this picture probably we can rewrite it with reanimated 3 and export reanimated support. So current version of Expo already support reanimated 3, as I understand from here. So we recommend using reanimated 3 with the picture component. So this probably can be rewritten with this picture. Yeah, it might be a bit advanced to start on Skia with this example, because there is no any explanation. So probably William probably needs start with William. And his Skia videos. Probably I'll pick some good one for the next stream. But for now we can, yeah, still try to understand. So my guess, we can rewrite it with picture in more performant way. We're actually using picture in our example. In the utils we create the picture, but then we draw inside drawing component. Not sure. Okay, this is maybe a bit advanced topic for now. Optimization. So the paint is something that can do the paint. Okay, there is no much explanation here. Maybe let's take a look at the canvas. Not much we can see here. Yeah, basically list of tutorials here. Maybe this is what should we pick next to learn more about Skia. Image filters, gradient noise, render passes, draw, no, custom drawing, but okay. Canvas clear. Context. Maybe we can just go to the source. Yeah, there is a documentation on the source. Clear fills the current clip with the given color using SRC blend mode. This has the effect of replacing all pixels contained by the clip and color. Yeah. So when we do the drawing, first what we do, we just fill all pixels with the black. Let's take a look if we comment it. So background just white in this case. Okay. Canvas save. Save, Skia matrix and clip. Calling restore, discards changing. Restoring the Skia matrix and clip to their state when save was called. Skia matrix may be changed by translate, scale, rotate, skew, concat, set matrix, and reset matrix. Clip may be changed by clip rect, clip rect, clip pass, clip region. Alright, and save. So before do some translate, we do save and restore. So let's comment out, and you see each translate affect other translates. It's like become wider and wider. But if we remove translate, we are fine. As doc says, we save in restored state for translate in this case. Alright. So draw picture will draw the picture, and this is understandable. And let's back to the util function and so we draw the squares but we clip the path with circles. So if we remove this part, I guess it will be full picture. And gesture isn't working. Interesting. How the clip path affects the translation of know what? Let's try chat GPT. Explain function line by line. So yeah, basically the image that you want to break into particles. Density is the distance between the particles. Okay, size, the size of each pen area, and yeah, canvas width and height. Skia paint object. This is for drawing operation. Okay. Loops to the stage. So yeah, we moving in X and Y by Density. This is actually interesting. Haven't noticed that we are moving not so density, it says it's distance between particles, and I'm not sure. So yeah, you see when I increase, it's actually increased the distance. But it looks like it's not between the particles, it's like between particle it's like if it will be 50, it's yeah, it touch each other, so it's like double of size. So if we want a distance between particles 10, we need to put there 60. And yeah, so in this case the distance is 5. And the steps is 35. In this case it's understandable, so each step is square 35 by 35, like x. Next iteration of loop, this is 35 by 35 these pixels, and next iteration by y is moved there. Alright. Yeah, basically you see we're drawing rect size of density and creating a picture. Then we do clip the pass. And here's the interesting part, is draw an image in rect. So this is the image, this is source C, the destination is paint. So image src distance, so this is the source rect and this is destination rect. So and we're drawing in always with 0, 0 coordinates, but before draw we translate minus x and y. So let's say the 0, 0 is here, and instead of drawing this here, we move canvas in this point. So this point of canvas match 0, 0, and then we draw it. I guess it allows us, when we do calculation on the pan gesture, ignore the position of particle on the canvas and just do calculation around 0 coordinates. But it's just my guess. I don't really know. Yeah, not super helpful. But still, density point give me some idea for investigation. So without the pan part, we don't need translation. We test it. So if we ignore pan, we can ignore this part. Yeah, it's a bit hard to understand without explanation because we change particle x and y here, then we change it again here, and we use it for calculations. So here x and y is not touched. Maybe let's ask ChatGPT about this function. Name line by line. Oh, by the way, thank you for the follow, Kitchik 95. Yeah, was like my experimental stream. I think I will try do more like this. Want to do things with React Native and cool stuff. Community share with YouTube tutorials, or maybe just plain GitHub code examples, etc. So yeah, stay tuned. Based on the palm movement, yes. Great. Gets particle from array. Distance between gesture point and particle. Okay. Yeah, this is part we understand by ourselves. Then there is the angle. Okay. Target coordinates. Main. I think it's actually should be max, not min. Let's rename it. So it calculates the final point for each particle around that in radius of 50, and each one should move out on the distance, max distance 50. So we need to calculate this point. Basically cosinus, cosine, yeah, cosine on distance basic trigonometry. Okay. So the question would be, for example, we have pan event here. So everything around should be move in radius. So for example, we have particle here and it should move here. And we calculate it with sinus and cosinus. We find this angle to x. So we find this angle. And to find x, we do this max. In our case it's 50. I don't know how it's trigonometry terms in English, but yeah, this is 50. And we do finding this x, multiplying this distance by cosinus of this angle. And then we subtract the event x so this x from this x, and we know exact distance yeah, same happened for the y. And then we save this and this in Vx and Vy. So this is basically distance between pan event and max radius for x and y. Now, when we're drawing, This is basically animation. So first time saved x and x will be 0 because in create picture it's the same. Then we have this distance multiplied by friction, and we add it to the x and y. So I'm just curious if I would way slower move out. Move. Okay. So the saved x and saved y, its initial position. So first iteration, this is 0, this is at 0, and when we first time have Vx and Vy, this will have plus 0, then we have Vx multiplied by friction, So let's say we have this is 10, then we multiply it and we have 8.8. And we then add to default position 8.8. Okay, there is no animation to move out, there is only it jumps immediately in the first step. To the max distance multiplied by friction, and afterwards we basically moving back. Vx and Vy decreasing. And yeah, difference also decreasing. So we basically, after move out, if it jumps out, it slowly move back. Yeah, I think we basically understand how it's working. I'm not sure where I want to use it anywhere, but yeah, this was interesting task to do. Interesting stream. So yeah, I think I will do more these ones. Thank you for watching. We'll see you next time.